Hello everybody, and welcome to my first YouTube programming video. So, as you can probably tell by the title, I have been using the LastPass password manager for probably over a year now, and I've been pretty happy with it, but they've definitely started to really nerf the free tier, and I've decided that instead of trying to pay for the paid tier and get a better experience, I can just write my own password manager. So I've looked into it and it seems actually fairly simple. So the first step, that in my opinion, is to write out all of the requirements and what I want to do and what I need to look into, and let's jump right into that. So, just in case some of you guys don't know, let's just start with what is a password manager. So basically what a password manager is it's a program that can store passwords, usernames and passwords, so logins, if I can type. And it can also store things like notes or bank information, things like that. Things that you wouldn't want people to have access to except for you. So basically what a password manager does is it keeps them all in one place, and you have a master password that you memorize, that only you know and that you don't store anywhere, and you type that in and it's able to give you all of your logins or notes or whatever you're storing there, and only you have access to that. So normally the master password is something pretty long and complicated that it's very difficult to guess, but instead of having to memorize multiple logins, you only have to memorize one really good one. So a lot of people just kind of use the same password for everything, or they just have super simple passwords, or they write them down somewhere. And obviously that has its downsides. It's if you write it down, if somebody finds it, then that's all gone. And in the case of using the same password for everything, or using simple passwords, if somebody does have access to your password and some hacker is able to get one of your passwords, then now they have the passwords to everything. So that's definitely a reason that you want to use a password manager. So now you might be wondering how a password manager actually works. So in the case of at least LastPass, they have all of this information available on their website. Basically, they take your email and your password and they hash it to create what's called a vault key. And that vault key and your password again are hashed to create what's called an authentication key. The vault key is used to decrypt and encrypt your vault, which your vault is just your stored logins or whatever you're storing in there. And then the authentication key is used to request your vault from the server. So in the case of LastPass, they don't actually know your password. All they know is your email and your authentication key, and then they just store your vault. So because of that separate layer of hashing to create your authentication key, they don't even know what your vault key is. So if they were hacked, then still only you are able to get into your vault. And your vault is encrypted behind that key, so there's basically no way that they can actually have access to your information. Everything happens either in your web browser or the phone app. All of this happens there, and then all the phone app does is request the vault, and it decrypts it right there so that the server never has your information. So a lot of what happens actually goes on the client side. So in this video, we are just going to be implementing the password manager backend. So I've written out some requirements. I think that it should be a REST API, which is just a type of API that allows you to communicate with the server and just send simple data and then get simple data back. It basically just simplifies the entire process of creating a front end for this. And I want the password manager backend to store the email. I want it to store the authentication key so that you can check if it's the correct person, and then I want it to store the encrypted vault. And that's all the data that the backend is actually going to store. It won't know anything except for those few things. And so I want a few different API endpoints. I think some endpoint for authentication, and an API endpoint is just a place that you send the data. It's a very specific type of request that you can make. I think authentication to just make the login process easy. It'll just check the authentication key against the database and see if it's a correct one. That'll just allow you to log into the app or website or whatever while it's requesting the vault. I think registration definitely makes sense to register for this password manager. Just in theory, we're going to be able to have multiple users and an endpoint to request the vault. Obviously, you give it your authentication key and it gives you back the encrypted vault. And then obviously a way to update the vault. In case you update your login information, you add a login, you add a note, you remove one, change a password, anything like that. That'll be updating the vault. And then finally, updating the authentication key or updating your password. So if you want to update your master password for your password manager, then we have an endpoint for that, just so that you can keep your security up, just in case somehow your password is compromised in any way. So I think this is a pretty good overview of what we want to do, and I think the next step is just getting a GitHub repository up and starting to flesh this out. Alright, so here we're going to make a new GitHub repository. We'll just call this Password Manager. And I guess this is my password manager. And I guess I'll leave it public so you guys can check out the code afterwards. I'll add a README, and I'm going to be doing this in Rust. So I'm going to add that gitignore template, and I guess we'll just add this license just for fun. Alright, so that's made. I'm just going to copy this link here, open up my terminal, go to where I store my Git repositories, and then I'll do a git clone right there. It already knows. Then I'll just go into the password manager and we can get started. So, first thing I'm going to do is do cargo init to create a new cargo package here. And let's just see. So I guess I'll add that, git commit. That's a pretty funny git message. And let's see. I guess I'll do ran cargo init. That's me for my password there. Okay. So we have that done. We're gonna do git checkout, develop, make a development branch. And then git push set upstream. It already knows. That's why I love fish. It's very good. So we have that all squared away. So I use Newcomb. So we're just gonna go right in here and open up the project. So I think I have decided that I am going to use something called Rocket. It's a Rust. Let's do rocket.rs. It is it's a Rust web framework, and it seems to be pretty great to use. I think we're going to be using the 0.05 release candidate, and so let's just see if we can get there from crates.io. Rocket. Okay. Doesn't look like it. I think it's still on the old version, so let's get started. And I'm just going to install this and then check out a few other dependencies. So this is what Rocket looks like when it starts up, and I guess we're just going to go directly to this link. You can see that we have the Hello World program running, so that's great. Let's stop that and go back in. As you can see, it's pretty simple. It has a lot of great macros, so all you have to do to make a new endpoint is just, write a function that returns something, and then just to start it up, we just do launch right here. And so I think the first thing is I'm going to get the database working. So I was thinking to actually store all of the information that we need, we can use an SQL database, which is pretty common. And I think I'm going to be using something called SQLite, which is just a file. You don't have to run some separate service or anything like that. So let me just see. I think Rocket has something in here. I think it's under state. think, yeah, databases. So right here. So, yeah, we're going to be using something called Diesel. Let me see if it... Diesel... Okay, it looks like it's in this crate. So I think we're just going to be using this, and this will allow us to use Diesel, which is a great Rust crate that allows you to do database actions, and all you have to do is write Rust code. You never have to write pretty much any SQL except for when you just create the database. So I guess I'm going to set this up. Alright, so right here is actually the only place when you're using Diesel that you actually need to write any SQL. So I guess just to explain, up is to create whatever you're doing. Diesel uses migrations, so you can do everything in steps. Up is supposed to do the operation, and then down is supposed to undo the operation. So we're just going to do a simple create table here. And we're going to call it users, just like we specified. And I think I'm going to create what's called an ID. So each user can have an ID. I think this is just going to make it easier when a user wants to change their password or something like that. So we're just going to do integer, not null. That way this can never be missing, because that's a thing in SQL. We're going to do, what is it, primary key, and then auto increment. An auto increment just means that we never have to keep track of these IDs ourselves. The SQLite is just going to take care of all of that for us. So then we're going to do, let's see, email. Email is going to be text, not null. And then it will want a key. So the key, I think, the key and the vault, sadly, I think I'm going to store them as hexadecimal text just to make it pretty easy. So this will also be text, not null. And then the vault itself is going to be text, not null. And then we do want each email to be unique. We don't want someone with the same email to try to register for two separate accounts. So we're going to enforce that within the SQL database itself. And I think that should be pretty much all that's there for that. Just for down, we'll do drop table users, and that will take care of all of that. So let's try to run this. Diesel migration run. Okay, running migration. Let's see, and we do have a data.db. Let's check it out. I do have SQLite 3 installed, and we can just check this out. So let's do, what is it? How do I... SQLite list tables. Look. Nope. Let's see. Select name from... Okay, let's just copy and paste this. And copy that there. And we can see users. So let's see if there's anything in there. Nope. Okay, so that's awesome. So we have all of that set up. And Diesel, when you run it, I believe creates a file called schema.rs. And all this does is actually allow you to have this generates all of the Rust code needed to interface with the library. So that's awesome. So we're just going to do mod schema to actually import that. Let's see, it's been a while. See the getting started here. Yep, we already wrote that. We already wrote that. Apply. Oh yeah, we should try to do redo just to make sure that all of our things work correctly. Redo. Yep, no errors. Awesome. Okay, so I think that's going to be useful just so we don't have to write all of the Diesel macros. And I guess we can do the same thing for Rocket, actually. extern crate rocket. That way we don't have to write out all of that. Let's see, I guess that's probably going to be useful. And then, yeah, so we don't need to do that yet. That's going to be different. I guess... yeah, okay, so we should make a models module here. Let's do source, models.rs. And this is pretty simple. I guess we just write a struct, and we derive queryable. So I'm going to actually set up all of this, and I'll get back to you when we have the database up and running with Rocket. So. Alright, so let's check out the state of our little program here. 404 not found, that's right, because I changed it to the .api endpoint, or actually they call it an index, just so that everything is on this API, so I can use the main URL for, that's not what I meant, the main URL for the web page interface. So right now the only endpoint that I have is auth, and right now it just takes, actually yeah, this is the correct output, because right now all it does is read the database. So close that. So right now auth just loads all the data from the database and then returns the string. So here we can see this is all you need to do to set up the database connection, and then you just add this to each endpoint and it gets the database connection, and then you can just do .run, and it's all asynchronous, so you do .await, and here we just load all of the users. We don't just every single one, and then we have a string that contains all of the emails that are listed, and those are just in plain text. So, and then we just return that. So right now there's actually no users in the database, so we can use that SQLite 3 and we can actually do insert. So we can do insert into users, and we can do, let's see, we don't need to do ID, but we need to do email, and then we need to do key, and then vault. So then we do values, and for email, let's just put in test@email.com. Key can be 5, and vault can be 2, I guess. That should work. Awesome. So now let's try to rerun it again and see how this does. So then we do auth, and as you can see, it prints out the email of the users in the database. So that's not very useful right now, but I think what I'm going to do is just start, I guess I'll start on the registration endpoint, and then see where it goes from there. And we will remove these .expects with actual error messages. I'll do that as well, just to get that started, so I don't fall into a bad habit. So now that it's actually done building here, let's actually run this, and we can see that, oh, that's just that endpoint, so let's do register. So currently, Firefox is no longer adequate for actually making the requests. You can see error 400, bad request. Actually, I want to replace this really quickly. Right now, let's see, requests, I think it is, you can actually register an error catcher. I want it to just be plain text, so I'm actually going to register my own. It actually says here, no 400 catcher registered using Rocket default, so I'm going to actually change that, and right here, make a new catch 400 bad request, and I think if I remember correctly, catchers may take 0, 1, or 2. Yeah, so I'm just going to put a static stir here and actually just say bad request, and that's all I need to do that. See, what do we do? You need to register, okay, register the catchers. Register, and then base, I guess let's do just API again. Catchers, that's a macro, and do bad request right there. Let's see. Yeah, we do have macro use on, so that should work. Alright, it's launched, and let's see if that helped. So now it just says bad request. Awesome. Yeah, so I just want that just so that it's easier to kind of tell from the front ends what's going on and be able to parse that. So Firefox is no longer adequate, so I have a program here called Postman, and it's a very nice tool. If you're ever trying to make any kind of API, you can do pretty much just raw HTTP requests any way that you want. So I'm just going to do 127.0.0.that, and then API, and let's say register. So we don't need that. We don't need that. We don't need that. We don't need that. Yeah, I think we need that. So let's see. So for register, I'm just going to put that in the background and go back to our code here. Right. Okay, so let's go to register, and I'll go through all the code really quickly just in here. So I made this guards.rs. This is just, you make these wrapper structs, and then you can do from request, and it allows you to take and check the inputs that you're getting before it actually runs this function here. And so I just wanted to check the vault, the email, and the authorization keys there. And so these are just small wrapper structs, and this just checks it. In this case, for vault, we just check if it's a valid hexadecimal string, and that's it. And then for email, we check if it has the @, and then here we check if it has the dot, for like .com or whatever. And if it's in the correct form, then we return it. If not, we do these outcome failures, and we say bad request, and then we give the reason. And the reason actually isn't given to the front ends. It's actually just logged here. You can see request guard email failed, email missing. So that's in our logs, which I did also add in our cargo.toml simple log and log here. And those are for the future. We'll get logging set up, so it's an actual service that you can run, and it'll log to a file so that you can just have it running, and you get nice logs of everything that happens instead of having to look at standard out or something like that. So anyway, I made those, and then I everything separated into its own endpoint files. So this is auth, this is register, and that's all we have right now. So we just have authenticate, and all it does is I made this helpful function check user exists, and it just checks if our authorization key is in the database somewhere. I might actually change that to use the email as well, but we can see about that in the future. Actually, these should be unique, so I think that's fine. And all this does is actually return 1 or 0, and we can check that out later. And that's very simple. Here we can see register user, and it takes the email, the authorization key, and the initial vault that the user wants to register with. It'll probably just be empty, and you can see it just checks if the user exists. That's just for the good error logging here, and then it actually makes the new user and inserts it into the database. And as you can see, we don't actually have to write any SQL at all, which is awesome. And that's actually all that we have right now. But you can see here, let's go back to cargo run. Okay, in Postman, we can do, what is it, X auth key, and it does expect it to be of a certain length. So I'm actually going to go into Firefox here, and this isn't necessarily the algorithm that we're going to be using, but 256 online. This is just the correct width. So let's just say for the key, let's just say 2, I guess. We can just copy this and put that in as the value, and then we also need email, so it's X email. And let's actually put something in here that's kind of sane, like test at email.com. Take that, and actually, that's right, this is plain text, so text at email.com, and then the vault. So actually we can use this for the initial vault is going to be hex, so that just works out, even though that's just test at email.com. So I think this is all the things that we actually need to put in the headers. I'm actually putting in the headers just because it's easier to make the all of those request guards for this. It might not be the best way, but putting them in the body, I'd have to put them in like some kind of JSON or binary data that I just didn't really want to do. And this just makes it super easy. So I think this should work. Let's hit send. Failed to write to database. Okay, let's check. It says 200 OK, which is strange. Let's go back here. It says request succeeded. Interesting. That's easy enough to start up. So let's check here. Register. That's spelled wrong. Let's see, string. Yeah, it said, what did it say? It said failed to write to database. And it had status 200. Oh, you know what we didn't do? In our guards here, or maybe not guards. Let's go back to this. In our response, we actually don't set that this is an error. So let's go, what is it? Content, not content type, status? Yeah, status. And so here we can use this. Let me just fix this. No, bad request. There we go. So let's just start that up again. I guess that doesn't answer why we got the bad data there. Let's hit send. Failed to write to database. At least we got 400 bad requests this time. Let's see what's actually going wrong. Actually, in order to check what's going wrong, I'm actually going to implement that that logging module, so I'll actually do that really quick. Alright, so I have that logging set up, so let's just try that again. Let's see, failed to write new user to database. Okay, let's check our code one more time. Failed to write new user to database. So the user doesn't already exist, that's not a concern. Let's see, execute, new user, users table. Okay, these will insert into. Okay, let's see here. See, we got that going. Let's see, yeah, schema. Well, let's put this, oops. Let's put this like that so we can check and read at the same time. We got values, new user. That's a string. That's our key, that's our vault. I use execute on the connection because we don't need the result back. Let's see. And then we, in the case of an error, we return this. In the case of a success, we return this. I'm not sure what the problem is here. Models insertable, table name users, email key vault, ID. Let's check just in case. Let's check our database. Select from users. Email 52, okay. You know what it could be? Okay, since we didn't do that correctly, we're reusing the same email, aren't we? Yep, test@email.com. Okay, let me just reset the diesel migration redo here. So now that should be empty, which is good. Okay, now let's try that again. Actually, that's kind of nice that our SQL... Oh, it's not running. It's kind of nice that we wrote our SQL that way. That's why you put all your constraints in your SQL saying that the email needs to be unique. That way you don't have to worry about it. Okay, send. We're registering. Okay, awesome, success. So that works now. Let's see if we can authorize. Let's see. So all we need to authorize is our authentication key. If I can click, okay, send, and we are authorized. So let's try a different auth key and see if that is wrong. So let's just put in, not 2. This is also, okay, we'll just use that. So, send, and we're not authorized. Awesome. So that's all working great. So I will just, now I will work on the rest of the endpoints, and I'll see you guys then. Alright, so we have the, hopefully we have the endpoint set up, so I'm just going to use the correct authentication key and try to get this endpoint, and let's see what it returns. Okay, so it looks like it's working, because our vault is this hex number, and it looks like that's this hex number, and it looks like it's successfully requested. Let's check it with the wrong authentication key. User does not exist in database. Okay, awesome. Very cool. Very cool. Okay. Yeah, so that's it. So let me just show you around the code a little bit here. It's not much. We just set up the get vault endpoint, and I've been having to change these names from get vault to request vault just because all of these macros seem to generate things in a weird way so that this can't tell what it is unless it's a different name. So I've created that, and then we just read vault from database, and we just set up logging here, request the user list that matches the auth key. We check just in case. It's just one extra if statement to see if we have more than one user, because that's definitely an issue that has the same authorization key. And then we actually just check if there was one by doing pop. This is a vector, so we just pop off the first value. And then, if there's none, then we say user no exists. And if there is, we just return user.vault. So that's pretty darn easy. And that's all we need to do. We don't need to interpret the vault in any particular way. It's just a hex string that we don't know what it is. And so let me just get on the next two endpoints here. Alright, so I think that I have it implemented, so let's actually try to get vault right here. That still works, awesome. So we will do, what is it? Update vault, okay, and we will set the new vault to, let's see, what should we set it to? I guess we can just set it to, we'll generate a new value. Let's see, let's see, this one is 70. There, that looks different. So it starts with FF now, so this is a different vault. We will try to set that. Okay, so update vault. Success, okay. Now let's try to read the vault again. Get vault, and if it starts with FF, then we're good. Awesome. So that works as well. And you may not think this is very secure, but you'll see on the front ends when we get to that this is actually very secure. And so I guess I'll try to implement that final endpoint where you update your password. Alright, so let's test if we have updated that correctly. Let's go to update key. And this is our authentication key. Okay, and this is the other one. I think, let me just quickly check if that's the case here. Send. Yep, okay, so this is the correct one. And we will do update key. And so this is our current authentication key. And this will be our new authentication key. And let's try to run that and see if we get a success. We do get a success. So now, let's just change this to auth key and try to authenticate. Awesome, so it works perfectly. That is all of our endpoints. Let me quickly go through the code here. It's not very much. We just set up update key, and we run this function here. It's pretty much the same as update vault, but we just filter on the old authentication key, and we set the key of the user to our new authentication key. And then we have all of our error checking and logging. I had to create this new guard type just because it needed to be a separate header key name. And so this is the only way I could think of doing that. I probably should separate this part out into some function somewhere. Actually, I'm going to do that right here, right now. Let's see. Yeah, let's actually do that right now. Pub verify auth key, and we're going to take. Actually, let's just take maybe key. So it's going to be an option of a string, and we're going to return an outcome, and that will be of, oh gosh, that's a little tough. You know what, actually I'll do that later. So yeah, it's actually very simple code. All of this is extremely simple. Not much needs to go and happen on the back end. I think this is actually us. So everything works, and I did save, so it's gonna have to recompile. But as soon as it does, yeah. So we actually have all endpoints of our REST API done. Bad request, okay, xvault, of course. This should return 0, and this should, yeah, I mean, everything seems to be working. So, I think that's it for this video. Next time I think I'm just going to implement a simple Python front end for this, and then after that's done, I think after that I will implement a JavaScript and CSS and HTML web front end for this that looks probably similar to LastPass, and see how well this is working. So I will see all of you guys in the next video.